Hello and welcome to 11-2 in the Big Ideas books. We are doing areas of circles and sectors. So what we did yesterday about trying to find the measure, we had the measure of that arc over 360, and then we multiplied by 2 pi r for the circumference. We're going to be doing something similar with that today because we're going to be doing it with areas of circles instead of just the circumference of circles. They're going to tie in very nicely together. First, we need to talk about a few formulas. So the formula for the area of a parallelogram is base times height, and we know that the height has to be perpendicular to the base. Circumference we talked about yesterday was 2 pi r, or sometimes people just do diameter times pi. So now the area of a circle, in case you don't remember what the formula for the area of a circle is, it is going to be pi r squared. So make sure you're using your radius squared. So pi r squared. All right, so here we go. Formula is pi r squared. What is the diameter of a circle with an area of 12.6 inches squared? So we have area equals pi r squared, and this time they want us to go backwards and we need to find out what the radius is. So we're going to plug in place of this area 12.6, and we've got pi r squared. So our order of operations dictates that we are going to divide by pi first, and then you're going to get some decimal in your calculator, and whatever decimal you get, you're now going to take the square root of that. So if you take 12.6 and divide by pi, use the pi key so that you're more exact, you get something like 4.01. And now if you take the square root of 4.01, you end up with the radius being something like 2.00, something to that effect. And since our radius is 2, we can now say that the diameter is going to be twice that. So that your diameter is going to be 4, and don't forget your label, inches. All right, next one, find the area of the whole circle here. So we've got area equals pi r squared, so we need to find this radius. Looks like they're counting by 2s, 2, 4, 6, 8. So it looks like the radius is 6. So if they're going to want an exact answer in here, we're going to put in 6 squared. So the exact answer would be 36 pi. This book seems to, I've looked at some of the section notes here and stuff, and they're asking us to round to the hundredths place, so 2 places beyond the decimal. So this one comes out to be 113.097. So if they want us to round to this 9, that 7 is going to make it go up. So it's going to be 113.10 if they want us to round that far. And they don't give us any labels, so we're going to call it units squared. All right, so that's the whole circle. So now, if we're doing the exact same circle, looks like they're counting by 2, 4, 6, so this radius is also 6. But now they want just this blue sector over here of the circle. How much is this of the whole thing? And I think most of you can look at that and say that that's 1/4. So we're going to take 1/4 of what we had, our 36 pi. So we can say this answer is going to come out as an exact answer of 9 pi. Or if we take 113.1 and divide by 4, I think it comes out to be something right around 28.3 units squared. Okay, again, where did this come from? Where does this 1/4 come from? Well, if we look at the whole circle, it's 360 degrees, and the portion that we want is 90. So if you take 90 over 360, these zeros cancel out, and 9 over 36 reduces to 1/4, and that's where we got this fraction of 1/4. Which leads us into this formula, which was very similar to yesterday. So yesterday was, instead of area of a sector, it was length of something, and then we just had this was the circumference instead of the radius. So really it's the same exact formula, just swapping out whether they're talking about area or if they're talking about circumference. All right, so let's see here. Find the area of the blue region. Well, again, we're going to take that sector there. So if the pink region would be 120 over 360, then that means the blue region is going to be 240 over 360 times pi radius squared. In this particular example, the radius is 14. So we're going to multiply by pi 14 squared. And when we multiply all of this out, I think the exact answer, leaving it in terms of pi, is 130 2/3 pi feet squared. And then if they want us to round this to, I can't remember, I rounded it to the 10th. So I got 410.5 feet squared. So let's see here. If we did 14 squared times pi, and we're going to multiply that by 240, and we're going to divide the whole thing by 360. Actually it rounds. If we go out to the 100th, it's 410.50 feet squared. All right, next question. Find the area of the given region. Anytime I'm asked to find the area of something, I write myself a plan. So my plan here, it looks like I have a half a circle, and then what I'm going to do is add to it a triangle. Usually when I write myself a plan, I do a better job of keeping all my numbers straight. So when I say half a circle, then I don't forget that it's 1/2 pi r squared. A lot of times we're thinking it in our brain, but then we actually forget to do it. So the triangle formula is 1/2 base times height. So I've got 1/2 pi. Now I need to know what my radius is. Well, if this whole diameter is 7, then my radius must be 3.5 plus 1/2, and it looks like in this triangle my base is 7 and my height is also 7. So now it's just a matter of plugging all of that into our calculators, and I rounded to the 10th for this particular answer. And so I got 43.7, and my label is going to be meters squared. So just remember to do that 1/2 because we don't want a whole circle. We only want half of the circle. All right, a rectangular wall has an entrance cut into it. You want to paint the wall. I think we want to paint that green part to the nearest square foot. What is the area of the region we need to paint? Again, I like to start with the full game plan here. So what I'm going to do is I'm going to take the whole wall, and the whole wall is going to be this 36 by this, what's that, 26? So 36 times 26. And then I'm going to subtract out. And what I have to subtract out is this alcove in here. So it looks like I have a rectangle that I need to subtract out, and I need to subtract out a half a circle. So that rectangle in here looks like it is going to be 16 over, and it looks like it's 16 down. So it's 16 by 16. And then I have to do this half a circle in here. And if that whole diameter is 16, it looks like my radius, pi, times my radius squared, is going to be 8 squared. So 36 times 20 gives me 936. 16 times 16 gives me 256. And 8 squared is 64. Half of that is 32 pi. And 32 pi as a decimal, I got minus 100.5. And if we subtract all of that, it comes roughly to 795.5 feet squared. And they want us to round to the nearest foot, I believe in here, round to the nearest square foot. So we would round this up to 580 feet squared. I think the book went through this problem and they must have used 3.14 instead of the pi key. So they got a little bit smaller of an answer because they weren't as accurate, because I think it rounded to like 579.47. So then they rounded it down to 579 feet. But when you're painting, in my opinion, you should always round that up so that you get it to the 580 feet anyway. All right, so hopefully this will be helpful for you. Your homework is going to be on line 11-2. If you guys want to, you can join us for the 10 o'clock Zoom, and toward the end or the middle end, I'm going to be doing a Kahoot, starting to do some Kahoot or different activities on Wednesdays to kind of liven things up a little bit. At any rate, hope you guys have a wonderful day, and we'll talk to you later. Bye.